Hello class, I have to apologize for not being able to be there today. So what we're going to be doing is going over some practice problems together through the video. So what you'll do is I will pose the problem, I'll talk about it, and I will tell you, okay, now do the problem. At that point, Mr. Emmer will come over and pause the video and give you guys time to indeed work on it. After that time, I will then go through it and you will need to follow me as we do it. One of the best tools you have available to you in a lesson like this is the person next to you. Someone around you will probably understand it by now if you're having trouble. So make sure, and I'm okay with you saying, hey, how did you do that thing right there? Or what am I doing wrong? I don't have a problem with that. Don't be unruly, but asking each other for help is a good thing. We talked about that on our rules talk day. So let's go over this problem here. We have two conducting spheres that are hanging by an insulated thread. One sphere has a charge of 5 microcoulombs, and the other has a charge of -7 microcoulombs. The spheres are 45 centimeters apart. What is the mutual electrostatic force between them? When we look at the word mutual, for example, here today, we need to think about what does that mean for us. Mutual. Is this charge pushing upon that, or rather pulling upon that charge? The answer is yes. Is this one pulling on that one? Yes, it's mutual. They're both doing it. Electrostatic is what we're studying, electrostatics. So take a moment and just kind of let's set up the problem here together. Bring our equation. Hey, come on now. Bring our equation up where we can see it a little better. And then let's start getting our variables set up here. So electric force, and there's our little dividing line. Let's get a little space there. Now, I've written things down one at a time here. Of course, we have Coulomb's constant thrown in right there. Then we have, this and that are ever so slightly different, yet they have the same meaning. If you've forgotten from the other day, remember we need to put it in meters, not centimeters. And I forgot my squared. Hold on just a second here, because I will steal a squared. There we go. So we got our distance squared there. What's next? My first charge. 5 microcoulombs. Remember that micro means 5 times 10 to the -6. That's what micro is. And then, thusly, it'll be -7 microcoulombs. Alright, so this is where you are going to pause the recording and practice this. I will wait a good 5 seconds of recording before I start revealing the answer. Alright, I'm ready to use my ultra cool calculator here. So let's plug through it here and see if you get the same answer as me. 8.99 exponent to the 9th times 5 exponent to the -6th times 7, that's negative, have to do it this way on my calculator, to the -6th. Hit my equals button. Now I need to divide that by, I'm going to put parenthesis here, 0.45, square it, close my parenthesis, equals. And I get, you may not be able to read it, but I get the answer that is -1.55. That's very tiny. -1.55 newtons. -1.55 newtons. The answer, negative, is significant in this problem. Let's look at that from a mathematical standpoint here. If we came up with a negative answer, that's because we multiplied two unlike signs, right? A positive thing and a negative thing. Give us a negative answer. Imagine for just a moment that this was instead a positive 7 microcoulombs. The only way this would change our answer is we'd end up with a positive answer. So in the original problem, negative and a positive, these two things are attracted to one another. In our little hypothetical, a positive and a positive would repel one another. What if instead of a hypothetical that's positive and that's positive, where this is instead a hypothetical negative? Negative and negative repel. So a positive and a positive repel, and a negative repel. What this shows us is if our answer for a force problem comes out positive, these are repelling forces. If instead our answer comes out negative, like this one did, that means that it's an attractive force. So when you're doing a Coulombs law problem, the sign of your answer will give you a clue that it's attractive or repulsive. So just kind of keep that little clue in your data bank. Let's do another problem. I tried to word this one the way they word things in the book. Two electrostatic point charges exist on the x-axis. So what that means is it's a electrostatic is what we're studying. It's a point charge, meaning a charge that is focused at one point. It's not like it's a metal marble, you know, a sizable object. We're putting all the charge at one small point. One charge has a magnitude of negative 2.3 microcoulombs, and the other has a charge of negative 5.6 microcoulombs. The first charge sits at the 0.5 meter mark on the x-axis, and the second one sits at the 1 meter mark. What is the electric force between them? Is it attractive or repulsive? Let's answer the last question first. A negative and a negative, are these going to attract or repel? Think about it for a second. 3, 2, 1. I hope you said it is going to repel because they're the same sign, they're going to repel one another. You'll know mathematically our answer should come out positive. Now let's work on solving this together. Drag this up where we can see it a little better. Ungroup it so I can copy things. Need to steal this, and I need to steal that for the problem. Alright, let's work through what we got on the board here. Of course, first things first, Coulomb's constant. And then we have a distance. Now, hopefully you figured out that the distance between the charges was half a meter. You may have to subtract two x-coordinates or y-coordinates to find a location. You know, half a meter to 1 meter, that's a distance of half a meter. So we got our distance there. Gotta steal a squared again. Half a meter squared. Then we look at our charges. Negative 2.3 microcoulombs and negative 5.6 microcoulombs. Remember to convert these into a usable number, times 10 to the negative 6th. And please remember that we are not subtracting. We are indeed, color will show up. We are indeed multiplying in these steps. Alright, go ahead and begin your solving. Alright, ready to solve. Here comes my calculator. Here we go. 8.99 times 10 to the 9th times 2.3, that's negative, to the negative 6th times 5.6, that's negative, to the negative 6th. Hit my equals button, and then I need to divide here by parenthesis 0.5 squared, close it, equals. And I get, if you can't read that, 0.46 newtons. 0.46 newtons. 0.46 newtons. That's what I get when I do that. If you guys have questions, you need to, again, ask your friends around you, and see if they can help you understand what we're doing here. Tomorrow, because I've missed 2 days and we had Labor Day off, we are not having a quiz tomorrow. Um, not having a quiz. I can't do that to you. It's not fair. So if you need further help, please go to the website. Look for other videos that I've done on the same topic. Look for section 6.2 or 16.2 rather. Look there. Go over the homework help again. The video that you guys watched in class it's on the front page, so it's right where you'll see it, same place where this video is located. Alright, please don't sit there and feel upset that you don't understand. Try to get help. Ask your friends, see if they can help you out. Alright, well, good luck.